This example, I'm going to show you how you can use our causal discovery in order to uncover the causal relationship between variables in your observational dataset. What I mean by observational data is the data you collected from your normal business processes instead of data from an A/B testing or a clinical trial experiment. For example, if I have a dataset of rental prices of different apartments, the dataset includes information from number of days of the apartment has been on the market, number of rooms, number of bathrooms, and the size of the apartment. Now, I want to understand how these factors affect each other. After selecting the dataset, I'm going to select causal discovery. In order for a causal discovery analysis to run, you need to select which features to be considered. So here, I'm going to use number of days on the market, number of bathrooms, number of rooms, rental price, and the square feet. First, we need to click on causal graph, and we need to select the constraints of different variables. So based on your domain knowledge, you can tell the models some prior knowledge of what are possible and what are not. For example, here I'm going to select the size of the apartment as a cost because I know that nothing else can affect it. And then I'm going to select rental price as an effect because I know that rental price cannot cause anything else. If you know any forbidden relationship, you can also set that, and the model will not use that as a file relationship. You can also tell the model what are potential causal relationships from the variable if you know it. And then you choose which model to be used in order to uncover the relationship. Here we support up to 4 different algorithms, including the latest deep learning algorithm called DexSci, and then direct linkum, Notice, and BC. Here I'm choosing direct linkum as simple, and we don't have to specify any parameters. And that's it. Now click run, and after a few seconds to a few minutes, depends on how big your dataset is, then you will be shown a causal directed acyclic graph. So here it is. So here it shows different nodes, which are different variables that we selected earlier, and the edges come from the cause and effect pairs. So here, for example, we have an edge that come out of number of rooms and come into number of bathroom, meaning that number of rooms will affect number of bathrooms. Similarly, number of rooms will have positive effect on the rental price. So the color of the edge, meaning that whether that cause had positive or negative effect to the target. So here we have a negative effect come from the number of days of the market to the rental price, meaning that the longer the apartment is on the market, then the rental price will reduce. So here, as we can see that rental price are mainly affected by number of rooms, number of bathrooms positively, and number of days on the market negatively. So now I'm going to select a more complicated data set. Here I have a data set of wine quality. This data set includes different information, including the percentage of alcohol, colorized citric acid, and so on. The causal graph, I'm going to choose alcohol can only be a cause, and the quality is an effect because it cannot affect anything else. And I'm not an expert in wine, so I don't know much about other relationship, whether they should be forbidden or not, so I'm going to leave it empty here. But that's it. I click run. So let's wait for a bit, and then after maybe a minute, then we should have a causal graph of these variables. So here it is. Now we can see that the model has found that alcohol have negative effect on density, right, but positive effect on sulfates. In terms of quality, then we have that pH have a relatively small negative effect on the quality. And the main one are alcohol, which has positive effect, which means more alcohol is better. And then volatile acidity has negative effect on the quality of wine. So that's it. This is a simple demo of our causal discovery. Of course, you can use different models. Each of them have different strengths and assumptions. We can list that in, you can check that out in our documentation. And so that's it. Thank you for watching.